Hello, my name's Nat and I'm from the National Space Academy. I'm here today in my teaching lab at the National Space Centre to talk to you about why it's really important that astronauts clip themselves onto the International Space Station. We're going to have a look at a quick demo and discuss some of Newton's laws. All you'll need for this is some blue tack, a sports bottle lid that you can open and close, a CD and a balloon.
Imagine you are on a spacewalk and you accidentally push off from your spaceship. If you are attached with a tether, you'll reach the end of your tether and then be able to pull yourself back using the tether. If, however, you are not attached to your spaceship, you will continue to move off in the direction that you pushed with the same velocity forever and ever. But why? Newton's first law tells us that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. This means that if you are moving, you will keep on moving. Your speed will not change, and neither will your direction. Here on Earth, if you give something motion, resistive forces from the surroundings and atmosphere will oppose that motion until the object decelerates to rest. Just like me trying to push this CD across the table, the friction from the table opposes the motion and causes the CD to decelerate to rest. Pause now and have a go. In space, there is nothing to provide those resistive forces, so you'll just keep on going and going and going and going and going.
That's why it's really important that astronauts doing a spacewalk stay tethered to their spaceship.
We can demonstrate this by doing our experiment. We're going to build a hovercraft. Our hovercraft reduces friction between the CD and the table. This means the resistive forces are much less, and the object's deceleration will be much smaller, just like in space. Obviously, we still have air resistance here on Earth, so if our hovercraft could float for long enough, it would eventually come to rest.
The first thing we're going to do to build our hovercraft is we're going to take our bottle lid, make sure that it's closed, and then take your blue tack, which you've rolled into a sausage. Place it carefully around the bottom of the bottle lid. It's important that it goes all the way around because we're trying to create a seal. Once you have done that, you can place it carefully over the hole in the CD. We want the air to go through the bottle lid and through the hole in the CD to create our hovercraft action, so it's really important that you create a good seal here. The next thing you're going to do is you're going to blow up your balloon and then carefully twist it, but don't tie it. The next bit is a little bit fiddly, so if you can get someone to help you, you're just going to carefully stretch your balloon over the lid of the bottle top. And now our hovercraft is ready to launch. We're going to carefully pull our bottle lid up so that it is open, and now we're ready to go. So it's really easy to see Newton's first law in action in space, and now you have a way to demonstrate it to your family and friends here on Earth as well.